Hello everyone, my name is Michael Tewitt and I am an astrobiologist at the Jet Propulsion Laboratory in sunny Pasadena, California. So what is astrobiology and what does an astrobiologist do? Well, there are lots of different approaches to astrobiology and it's a very multidisciplinary scientific enterprise. My particular interest and expertise is in the study of things that are long dead. That is, I'm not an expert on radio signals from alien civilizations, nor am I looking for microbes that are currently alive, say somewhere on one of the icy planets. My interest is in the evidence of ancient life in ancient rocks, much like we go out try to find that here on the Earth. So that evidence can take many forms. We call those biosignatures. And so a biosignature could be an elemental distribution or a molecular fossil. That is like petroleum is a biosignature. It's a form of molecule that was from something that lived long ago. We also look for isotopic signals. That is when biological activity takes place and differentiates one isotope over another, that leaves a signal in the rock record. We're also looking at morphology, that is shapes. Obviously the most obvious would be a dinosaur skeleton. We don't anticipate finding dinosaur skeletons, but that is an example of a morphological biosignature. As you can imagine, any claim that something was once alive beyond the Earth is going to be an extraordinary claim, right? It's going to require an extraordinary evidence to support that. And so any single line of evidence is not going to be sufficient, obviously except for that dinosaur skull. But that's not going to happen. So astrobiology, especially with respect to biosignatures, we've got to have multiple reinforcing lines of evidence. So I want isotopic evidence, I want molecular evidence, I want morphological and textural evidence. It's going to take all of those lines of evidence to actually say with some confidence that yes, life did exist at some point beyond the Earth. So, how do I do that? Well, how does an astrobiologist like me spend his day? Well, probably like you, I spend a lot of my days sitting at the computer. And so on the unpleasant side, there's an awful lot of administration to be done, right? There's always grants to be written and paperwork to be done and safety stuff to follow up on, and oh, that's such a drag. But there's also data analysis. There's also writing. So as a scientist, you do a good deal of writing. I'm an expert myself in writing procrastination, which is actually what I'm doing at this very moment. But in addition, sometimes then for a lesser amount of time, I get to spend in the laboratory. And that's that I take the rocks that I've collected and I grind them up and then I subject them to all kinds of abuse with acids and solvents and lasers and x-rays just to pull what information I can out of them. In the ideal day, however, I'm out in the field, all right, maybe with Professor Flannery, collecting rocks at some exotic and remote location, something that no one's ever seen before, in hopes of making a discovery that's unique to science and will inform how it is that we might look for signs of life on another planet, say Mars. So, speaking of Mars, by the time you hear this, the Mars 2020 will have launched, the Perseverance rover will have launched, and I will be on its way to Mars, I hope. That should be the case. And so increasingly a good deal of my day-to-day activity is taken up in the planning for the operations of that rover on the surface of the planet. Mars 2020, or the Perseverance rover, to give it its proper name, will be unique in the history of exploration on Mars, because what it's going to be doing, in addition to having a number of instruments that are looking, say, specifically for biosignatures or other geological information, Mars 2020 will collect individual samples, little cores about the size of your index finger, and it will lay them down on the surface of the planet, and then in a few years' time, hopefully in 3 or 4 years later, another spacecraft will arrive, pick up those samples, bring them back to a small rocket, and send those back to the Earth, where people like me will have an opportunity to examine them in detail. Because though the instruments that we send on a rover like Perseverance are exceptionally sensitive and useful, they're nowhere near the kind of the sensitivity or the capabilities that we have with the instruments that we have here back on Earth. And as I said, claims to biogenicity, that is a claim that something was once alive, will require extraordinary evidence, and it's going to require the kind of instrumentation and the kind of science that we can only do here on the planet. So, for the next few years, my time will be consumed largely in operations of the actual rover, that is day-to-day operations of that machine as it explores the planet looking for biosignatures. And I'll also be spending an awful lot of time here on the Earth trying to find rocks like the ones we see on Mars and analyzing those in anticipation of that day, probably 10 years from now, when those samples return and we get to crack those open and really look closely for those biosignatures. So the next decade offers an extraordinary opportunity in astrobiology for the discovery of evidence for ancient life or even current life on a place like Europa, the object of the upcoming Europa Clipper mission. This is a golden era. We could, within our lifetimes, definitively answer the question, are we alone? Does life or has life ever existed beyond the Earth? And that's a big one.